Good afternoon and welcome to your science review with Mr. Blades. Today we're going to be going a little bit over velocity versus time graphs. I'm going to give you some examples and explain what they mean. Okay, so as you can see, I have 4 example velocity versus time graphs. We have velocity in meters per second on our y-axis and time in seconds on our x-axis. I have 4 examples here, and I'm going to go ahead and explain what each one of them means. The red line is our graphed velocity. So here on my first graph up here, this looks like a flat line at 0. So what does that mean on a velocity versus time graph? As we can see, our velocity is here at 0, and with a flat line, it means that the velocity is not changing. So when your graph of velocity versus time looks like this, it means that your velocity is equal to 0. Now over here, it might be a little small and hard to tell, but we have a 5 up here on our y-axis, and that is where our velocity is coming out of. We have another horizontal line similar to our first graph over here, and again what this means is that our velocity is not changing. However, in this graph we have evidence that our velocity is equal to 5 and not changing. So our velocity here is equal to 5 meters per second and is not changing. Now, down here we have a velocity that is not merely a horizontal line. It is an increasing line with a positive slope that starts above 0. Now, as you can see written right here, the distance between 0 and wherever our graph starts is the initial velocity. So what this means is this graph started with a positive initial velocity, positive, and accelerated and continued to move faster as the line increased. And for an added bonus, the slope of this line is equal to the acceleration of our line. So again, this graph depicts a velocity that starts at whatever the initial is and increases at the rate equal to the slope of this line. Okay. Now, in this line, just as I mentioned over here, the slope of this line is also equal to the acceleration, but as we can tell from the direction the line is pointing, this acceleration is negative. Now, negative can sometimes mean slowing down and can sometimes mean speeding up. So, just like in our last example over here, our initial velocity in this example is wherever this, from 0 to up here. Whatever this is our initial velocity. From up here, as long as the velocity remains positive, we can see that the velocity is getting closer and closer to 0. So from right here, the velocity is slowing down. But the second it crosses 0, right there, at that moment where it crosses 0, the object will stop for a very brief second, and then will accelerate, go faster and faster, in the negative direction. So if your graph looks like this, you have an object that is starting out moving, slows down while still traveling in the positive direction, stops momentarily, and accelerates in the negative direction, continuing to move faster and faster. Now, I hope all of this was helpful, and I'll see you in class.